All right, ladies and gentlemen, we're going to talk about angle, side angle, and angle, angle, side. So continuing with triangle congruence, we started with side, side, side. Then we did side, angle, side, and hypotenuse leg. Now we've got a couple more. So the first one is angle, side, angle, angle, side, angle. So ASA is our abbreviation. Congruence postulate says if two angles in the included side of one triangle are congruent to two angles in the included side of a second triangle, then the two triangles are congruent. So an included side is a side that is in between the two angles, or if you trace over the angles, you're tracing over the side both times. So for instance here, if I look at angle A and angle C, the included side is this side that I went over twice, that AC. So here, in these two triangles, it's saying angle A is congruent to angle D, because they both have the single arc. It's saying side AC is congruent to side DF, because they both have the single tick mark. And then it's saying angle C is congruent to angle F, because they both have the double arcs. Recall that when you state segments congruent, you need to make sure that you line up the congruent angles. So A and D were congruent, so they are both first. C and F are congruent, so they are both second. So then my congruent statement says triangle ABC is congruent to triangle DEF. Again, lining up our congruent angles because order matters. All right, so then next I've got angle, angle, side. Angle, angle, side, so abbreviated AAS. If two angles in a non-included side of one triangle are congruent to two angles in the corresponding non-included side of a second triangle, then the two triangles are congruent. So not included. So if I trace over my two angles, A and C, I only go over the line one time, or the segment one time rather than two, like I did for that included side up above. All right, so naming the congruent pieces of this triangle, angle A is congruent to angle D. Angle C is congruent to angle F, okay, based on the number of arcs in the picture. And then BC is congruent to EF, based on having the single tick mark. So then my congruent statement would say that triangle ABC is congruent to triangle DEF. Again, order matters. Your congruent angles should be in the same location relative to the name. All right, so can the triangles be proven congruent with the given information in the diagram? If so, state the postulate or theorem you would use. So the two from today are angle, angle, side, and angle, side, angle. Okay, remember from previous lessons, we had side, 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 angle, side, and hypotenuse leg. All right, so if I look at this first picture, I've got an angle and an angle. I've got an angle and an angle. So I have to determine, do I have a side? I don't see any tick marks on my picture, so no, I cannot prove these congruent. Every one of our theorems or postulates has at least one side where I know something about it. All right, moving to the next one. I've got an angle and an angle. I've got a side and a side. And then I have to determine if there's anything else I know. So I've got vertical angles, this angle here and this angle here. So I have two angles and a side. So now I need to determine what the order is. So I need to determine if the side is included in the angles or not. So I'm going to trace over them. So if I trace over the red angle and trace over the blue angle, I get that purple there where I traced over the side twice. So it's included. So this is angle, side, angle. The side was between the two angles, so the S is between the two A's. All right, moving to the third one. So I've got these angles here. I've got these angles here. So I've got two angles. Is there anything else I know? I've got that shared side, so I could add a tick mark. So I have two angles and a side. I need to determine if the side is included or not. So if I trace over my angles again, here's one, here's the other. It's only necessary to do it in one triangle. I didn't trace over the side with the tick mark twice, only once. So this is the non-included side. So this is angle, angle, side. All right, moving to the next one. I've got a pair of sides. I've got a set of angles. And again, I've got a shared side. So I can add my tick marks. Okay, so this is side, angle, side. I know that because if I draw that angle, it's included in the two sides. It makes up the two sides that have the tick marks make up that angle. So this is from a previous lesson. This one is side, angle, side. Side, angle, side. All right, your favorite thing, proofs. All right, so again, first thing you want to do is mark the picture with what you were given as well as what you already know. So BE congruent to BC, those are your tick marks. Angle A is congruent to angle D, those are the arcs. Okay, what else do you know? Hopefully you know vertical angles are congruent, so this angle here and this angle here could also be marked. So now I have an angle, and a side, and I have to determine which of the two that contain two angles and a side it is. So I have to determine if I have an included side or not. So if I trace over my angles, here's one, here's the other. The side I traced over twice was this one here, BD. It's not where the tick mark is, so therefore the side is not included, so it's going to use that top theorem, angle, angle, side. So I haven't even set up my proof yet, but I know every answer or every component just based on the picture. All right, so I've got my given. Put it on one line or two, it doesn't make a difference. Okay, then I added those vertical angles. So now I'm going to state they're congruent. So there's two angles with a vertex of B, so it's important that I use 3 letters. So it's going to be angle A, B, E is congruent to angle D, B, C. And again, those are vertical angles. Okay, vertical angles congruence theorem. All right, so now I have enough information. I have a side and 2 angles, so I can say my triangles are congruent, which was my proof. So triangle A, B, E is congruent to triangle D, B, C, and the reason is the angle, angle, side congruence theorem. All right, so moving to example 3. If you weren't done with example 2, go back, rewind the video, and watch it again. All right, so I've got VW is congruent to XY. So here's VW and XY. That's this one. WX is congruent to YV. So WX, YV, that's this one. What else do you know? Hopefully you know that you can add tick marks for that shared side. That shared side. So I've got side, side, side here is going to be my reason. All right, so I'm going to set up my proof. Start with those givens. Okay, then put in the tick marks that you added. So that's VX is congruent. Let's see, if I do VX from going this way, it's going from the double tick marks to the single tick marks. So from the other triangle, if I'm using the top one, then it'd be XV. And something's congruent to itself is the reflexive property. And this is a POC because I'm using congruence. And now I have 3 sides, so I can say my triangles are congruent. And the reason is side, side, side. Congruence postulate. That's it. If you are unsure about anything, please consider rewinding the video, starting it over, and watching it again. Thank you.